Okay, welcome, Navin. Thank you for having this conversation. Today, we're going to talk all things enterprise data management, and Gen AI. I see what's on your shirt, so I'm sure we'll talk about hallucination, but
Right.
I would love to have you talk a little bit more about your background.
Well, thank you, Joyce. Thanks for having me on this call today. So my name is Navin Sharma. As you mentioned, I've spent about 25 years of my career in the data management space in a multitude of roles, mostly in enterprise software, B2B space. So that career spanned everything from consulting on large data quality initiatives in the early days, when data quality was a big challenge for companies and continues to be, as we still know, garbage in, garbage out stays true to form, even now in the Gen AI era. Moved into spending a lot of time in more of a solution consultant role, working with large enterprise organizations across industries, banking, insurance, retail, PubSec, and then about about 15 years ago, I got really entrepreneurial with where I thought, our products needed to be in the market relative to competitors. I'm very competitive by nature. And I found religion in product management and product. And I figured that would be the right place for me. Love the idea of building products that create value for companies, and learning more about solving companies, organizational challenges through software, which I was very passionate about. So it was the right fit. And 15 years later, I've never looked back. So I now head a product here at Stardog, and really excited to continue, innovating and building and new products that create value for our clients.
So we will talk about Stardog later, but
Yeah.
I always think of you as someone who has really been immersed in data management and understanding the challenges with enterprise data. And as
Yes.
you said, everything looks great until we get into enterprise data. It's messy, it's big, it's
Yes.
complicated. What
Yep.
is the state of data management today as an expert observing
Yeah.
the space and working the space?
Yeah, I feel like I'm gonna get a lot of folks here that are listening, the listening audience in a whole heap of trouble by saying that the state of affairs, frankly, hasn't evolved to the level that I would have thought that we would all want it from an enterprise perspective, right? What I've seen is companies have spent a more enormous amount of time sort of band-aiding solutions back in the days inside of their enterprise within on-premise environments, right? From the evolution of the mainframe to open systems and Unix and Linux, to a shift to cloud. And the shift to cloud was always about sort of unit economics, providing some agility with respect to infrastructure. But at the end of the day, the data management practices really didn't involve with the United mindset that we need to look at approaches differently. We need to innovate differently in ways that we manage data, ultimately providing flexibility in ways data is consumed in order to drive decision making. So even in today's world, yes, a lot of data has evolved. In fact, we've opened up new ways of storing data to make things more efficient, to maybe be more purposeful in the types of queries that we want to create and respond to specific business problems and business domains. But at the end of the day, we're just creating more silos, right? More silos in the cloud, more silos in the way data is organized differently. Shift to the data lake was all about, let's bring everything in one place. At the end of the day, it's, the data lakes have turned into data swamps. I'm sure that's a term it's talked about quite a bit in the industry. And then you've seen what the major cloud providers have done is really capitalize on the shift to bringing your data into the cloud environment, to then saying, why not create better structure and curate information that you need from a reporting purposes. So what they've done is essentially created the same stack that we've had on-prem, now on the cloud, with the data lake sort of as the underpinning of where all your data sits, right? But what we have still lost is the ability to drive agility when it comes to looking at data different ways, slicing data different ways, understanding what data really means, making data findable for users who need to consume information in ways that's relevant for their business use cases. So that is still a miss with respect to the evolution from on-prem to cloud. And ultimately, all we've done, like I said, is created the same stack, called it modern, put a new label on it called the data fabric. Ultimately, it's just the same data that we've had in a lot of enterprise systems and on-prem, now just running in the cloud.
And it's a hard problem. And I think that organizations have lots of data. Do you see the nature of the workload of data change, or even have gotten bigger because of structure, different types of unstructured data, different types of structured data, the different jurisdictions that these data sit in?
Yeah.
Just give audience a sense of sort of specific examples of why this is such a big problem, in addition to the infrastructure challenges, and how the industry is trying to solve that for clients or
Yes.
customers. But of course, customers themselves are dealing with just the sprawling and growth of data.
Data sprawl is a huge issue for sure, right? Every time you need to answer a business question, you need to move and copy data, curate it for a certain purpose, and then enable it for consumption. So workloads, right? And we talk about workloads. So one of the benefits, I know I kind of came out strongly negative with respect to the shift to the cloud. Yes, it had some benefits economically, but one of the other benefits of operating in the cloud, along with the economic benefits, were the fact that we could process a lot more data, right? So the big data workloads that people wanted to look and manage every clickstream data, every social interaction, every log information. That was what the big data processing workloads were designed for. And certainly the infrastructure with the evolution of Spark, Databricks being a big vendor in that space, was able to bring that kind of scale, and on top of that, drive sort of the analytics, the machine learning ops aspects as well, right? The machine learning workloads on that scale of big data. So those were all the positives. I think at the end of the day, where companies have still been challenged with and continue to be challenged with is the fact that data, in order for it to be consumed, needs to be done in ways that the end consumer can fully understand the full extent to what that data means, how that data connects, how that data relates to other pieces of information that exist in the enterprise. And so that meaning, that connection, being able to elevate data in ways that can be consumed easily without having to create more data sprawl. Let's create another data lake, or let's create a small lake. Let's create a very specific data mart or data warehouse on top of the data lake. That continues to be a challenge, right? Every time a business question needs to be answered with a slice of data that perhaps needs to be curated in order to make that possible for the consumers. So I think the mind shift is still very much about storing and modeling data where it is physically stored, right? Where the data is produced on the production side. Where I believe the shift now that we're seeing is more on the consumption side, which is how does that data need to be consumed? So then why not model for information in ways that tells us how the data needs to be consumed and what it means, and then figure out where the data is from a sourcing perspective in order to fulfill the questions and the answers that need to be addressed. So the shift towards consumers is really the major shift we're beginning to see.
Yeah.
In the
And I
market.
think that ties very nicely to where we are today, because as
Absolutely.
consumers, ChatGPT came out, and
That's
it was
correct.
really interesting
That's right.
that we can just type into a
That's
box
correct.
and query
That's right.
for information or for quote unquote insights.
That's right.
And it's much harder in the enterprise,
Yes.
because as we talked about this, it's one thing to ask a question about what's the revenue growth this year compared to last year. There's only one answer. But then when you ask another question, which customers drove that growth?
Correct.
which customers churned,
That's
which
right.
customers did better on this product versus another product in which geography. It no longer is just one single answer. It's now, as you talked about, it's business intelligence. It's the business users want to ask those free form questions
Yes.
and have answers that have depth and
Yeah.
substance and more analytical grounding, and that's business intelligence.
Correct.
And so let's talk about that.
Yeah.
So I think
Yeah.
that's one of what you're working on 24/7 is how to bring that
Yes.
experience, that ability to query for business intelligence to the users, no matter where they are in functional areas and departments. They don't need to rely necessarily on another data scientist or another business analyst. This should be something that once it's built with the right data management, data structure, and data modeling, that the sort of the business intelligence layer
Oh, absolutely.
with the generative AI capabilities make it much more compelling and feasible.
Yeah, absolutely. If you think about the holy grail has always been this notion of data democratization. Right? We've talked about this for a long time, even back 15, 20 years, the idea of data democratization, data self-service, the idea that any user can access data and be more data-driven in an enterprise. The fundamental problem, even today, when we think about the challenges for a sec, have been in how you model information. They're tightly coupled. The modeling of the data and the information is tightly coupled with how data needs to be stored and structured. Right? So that does not lend itself to thinking about how in the real world, how data and information correlates. And when I say data and information, which basically together combines to create knowledge, that piece where I have to now, if I need to change something, if I need to add a new dimension, if I want to look at data with a different lens, I need to fundamentally go back into my source system, change the underlying structure of the information, reshape my data every time I have to answer a business question, right? So it's the data modeling that you highlighted aspects that you need to shift away from where the data is stored to how the data needs to be consumed. And that's where there's the notion of a semantic data layer that was prominently highlighted almost 15 years ago by the BI vendors, like your Tableaus and their new Power BIs of the world. But that notion now needs to be done in ways that scales across the enterprise, not just specific to a BI tool, right? So it was the right idea, but the focus was very limited, and focus was limited in the context of that tool. Now the notion of a semantic data layer, kind of that sits on top of all your enterprise data, is how you model information in terms of how you understand information. In the real world, we know relationships are many to many, right? But in an optimized database query that's structured in a relational database somewhere, you need to have the one-to-many construct, the third normal form, right? So in the way you need to shape data for efficient query processing, not necessarily for how you need to understand data in terms of what it means and how it connects to the rest of the information that exists in the enterprise. And so that semantic data layer that's sort of sitting on top of your enterprise data environment, enterprise data lakes, your enterprise data warehouses, is the way organizations will bring that level of flexibility, agility they need to not only look at data one way, but look at data many ways. So they could put multiple lenses, including adding their own business logic within that semantic layer, so that risk and compliance teams can look at it a certain way, sales and marketing teams can look at it a certain way, someone on the product side can look at it a certain way, but I don't have to necessarily go down to the level of how the data is stored and reshape that every time I need to answer a new question for a new user or a use case or a persona. And
I
that's
think
one
key.
aspect of it.
Yeah, I think that's key. And so maybe I play back to you on that
Yep.
because I think that's one of the things I learned from you. And then we'll talk about Gen AI. And we'll
Yes,
talk about what does it mean to stop hallucinating, because that's top of mind for everybody working with large language models and Gen AI today.
that's correct.
So I think what you're saying is that there is a needed decoupling
That's right.
of components in this entire kind of data management to business intelligence, knowledge retrieval process, if you
That's right.
will.
That's right.
And in the past, it may be the case that specific type of query of knowledge or business intelligence from a specific data set or data sets, or then those are stored in a very specific way. And if a question were asked differently against those data sets, they may have to be enriched or restructured in terms of how it's formatted and so forth.
Correct.
And the world that you want to build and you're the team want to build is, hey, we need to decouple this. So no matter where your data workload is, on-prem, on cloud, regardless of cloud provider, no matter the type of workload,
That's right.
the data modeling is more important and it should be a flexible layer
That's right.
that state the truth, the ground
Yes,
truth
that's
among
correct.
data points and relationships, because those stay true and those can continue to build
That's right.
and evolve.
No matter what the tool is
So,
underneath, no matter what the tool is right above, right? That's the
right. Yeah. And then the data modeling layer decouples from how the data is stored, where they're stored, how they're formatted, because they know now it's no matter what the team need to do on more of the infrastructure fundamental layer, the data modeling is the brain and the engine that will power the semantics, or in other words, to create that knowledge
that's
graph, if you will,
the
that
semantic
connect
layer.
these different points and
Absolutely.
extend that to the business intelligence. And then there is effective user interface and front end to allow the end users to query for knowledge.
That's correct, right?
Okay.
You can support a multitude of personas, your BI writers, your ML notebook creators, your application developers, they all can have that consistency through that semantic data layer that encapsulates your knowledge representation of your business and business concepts and relationships, along with and any added business logic that's relevant for the different teams. So you can put multiple lenses, decoupled away from where the data is stored and structured. Now,
I love that. Yeah, I think that makes sense, right? That makes sense to everybody. And it provides flexibility, as you said. And I think also now, large language model is an
That's right.
example of that, which is something that's very powerful, that the benefit of it is that it can generalize fairly well.
Yes,
Although it has its shortcomings, and we'll talk about those, and hallucination is one of them, but it does pretty well. And based on what you just discussed, that there are a lot more, beneath the surface, right? Behind the large language model, behind other techniques for querying for knowledge, looking for in-depth business intelligence. And part of that is that generalizable data intelligence layer or data modeling layer that can accommodate to the different kind of infrastructure as well as the things above that, if we're thinking in a stack world. So now let's talk about Gen AI.
correct.
So where does Stardog fit in? I know there are different school of thoughts.
Yeah.
For the audience here, I think most are working in Gen AI. And so people understand the different techniques in terms of retrieval of information, which is key,
Yeah.
right? So everybody understand the front end and the user experience. We don't have to talk about that. We don't have to talk about the infrastructure side. But what's really important and what's really hard is that middle part.
That's right.
How do we find the right information? How do we retrieve the right information to provide exactly what the users are asking,
That's right.
and also prevent hallucination or fake information, what have you?
Yeah, I mean, so basically you're asking, I want a chat GPT type experience, but on my own enterprise data. Now
Right.
that you've
Yeah.
you've always had your data in your data lakes, we've talked about, the explosion of information, on-prem and cloud and data lakes and data warehouses. We've talked about the value of putting this sort of semantic layer, the semantic lens that harmonizes all this data through and creates that business meaning layer on top of your enterprise data. That is the mechanism through which we now can enable large language models. And this notion of a semantic layer are also referenced quite a bit in a lot of research papers, even including Gartner, called knowledge graphs. So the idea there is that you've created this sort of knowledge representation of your enterprise data in the semantic layer. That is how you ground information and ground truth about the enterprise and what the information it consists and contains. And then instead of relying on large language models as the source of the information, you now essentially, and that's where we've been working, our engineering team has been working very hard, building out the capabilities where we leverage the large language model, not necessarily to go ask questions about your data, but use it to generate the queries that are needed from a semantic layer perspective to then execute against your enterprise source systems. So what does that look like in an experience standpoint? I ask a question, we identify what business concepts are relevant in order to answer that question based on that semantic data model, that data model representation that says customers are connected to orders, orders have different suppliers associated with it, suppliers supply certain parts. Those concepts and those relationships allow us to, first of all, ground the response in terms of that knowledge representation. We then use that to go to the large language model to actually generate the queries for Stardog. And then using that query that gets generated, we execute that against your enterprise system. So one of the benefits of the Stardog system has always been to go into your enterprise in a federated querying manner where we leave data in place. So we know that for customers, we need to go to Snowflake. For suppliers, we need to go to Databricks. For parts, we need to go into a third system. And we bring that information from your enterprise systems based on those concepts that have been identified in terms of the question that's being asked. And when we get the answer, we then use a large language model to summarize that response back to you in plain English. So there are no hallucinations. And that's one of the things we've been very proud of in terms of the work that we're doing, is to ensure that there's no hallucination, especially when you talk about regulated industries and working with your proprietary enterprise data. Hallucinations, there's no room for hallucinations, right? Because you will not see any adoption of any GenAI inside of those types of organizations. And so having that semantic data model be the layer through which you actually put the ground truth about your representation of your enterprise information, and then our ability to access data at the source without moving or copying it, so that we don't rely on the large language model, but we actually go into your enterprise systems to fetch the relevant information that we need to answer the question. Those are the combined value of the solution now enables that kind of experience for any knowledge worker inside the enterprise. Ask a question in plain language, get a response, and know that the answers that are coming back are 100% accurate, hallucination-free, and grounded in sort of your knowledge representation of your enterprise information.
Can we do a quick example?
Yeah. So let's take
yeah. So maybe let's take the same example that, if I'm asking as a business user, what's the year-over-year growth of revenue of business unit A? And imagine there are multiple business units in this global company, in a regulated industry. We don't need large language model. We don't need any of that. This is really a simple calculation to do that. But if the question is, please tell me the year-over-year growth of my business unit and break down the key products that drove the growth, and give me the contribution margin, that's more complicated.
Yes.
Right? And also tell me which account executives are assigned to the customers that drove the growth that we see year over year. So now you have financial analysis, you have people and relationships, so entities, and it's sort of, that's like the semantic layer, the small version, a very small version of that.
Very small version of the semantic layer.
Use that as example. How does that translate to what you said on what Stardog does And
Yeah.
then what does it give to the large language model and what comes back?
Okay, good. Let's talk through that scenario. So you asked the question, we reference based. So first of all, we take your question and we do something called semantic parsing, right? So we identify key concepts that are in the question that are being reflected in the text. So the question text. Once we have identified the key concepts in the text, we identify what part of the semantic model do we need to reference in order to align with the concepts that were in the question. So we know that financial information is tied to products. Products are tied to customers that have purchased those products. The customers are tied to accounts and account execs that actually have relationships with them. And so in order to fetch all of this information, I need to understand this sort of small, to your point, this a small version of the semantic data model. And what we do is we send that small version of the semantic data model to the large language model and use it. And this is a part of our solution, is this fine-tuned large language model. And we use several large language models that we have fine-tuned for this purpose. We use it to generate a query based on that semantic data model. So once that query is returned, what is also important as part of our system is those semantic concepts of financial, customers, products, accounts, people. Those entities are mapped to your enterprise system. So where I know that in order to get the finance information, I need to go into Oracle. In order to get the people and data, I need to go to HR. In order to get product information, I need to go into your PLM, product lifecycle, product information management system. And those mappings have already taken place because we know that those concepts relate to data that sits in these systems. So when we execute that query, now what we do is we sort of federate querying into those systems in real time. We get those information from those systems brought back and linked together through that semantic data model. And then we use the large language model to summarize the answer in plain language and send that back to the user. So it's number one, it's timely. So we're getting access to your enterprise system at the time you're asking the question. So you're getting real up-to-date information. It's accurate because we're not trusting the large language model for the answers. We're trusting your systems of records for the answer. And number three is hallucination-free. What that really means is if you ask the question outside of the realm of that semantic data model, then our system is designed to say, we're not going to answer that question because we don't have any knowledge of that. That knowledge is not represented in the semantic model.
Okay.
Right?
And so the query from the large language model, using your example, is actually create queries to automatically retrieve information, understanding where those data are stored,
That's
and
right.
what type of information needs to be retrieved,
That's
and
right.
what specific piece of information or data need to be retrieved.
Correct. That's correct.
So that's the first role of large language model
In our system.
stack.
Correct.
And the second part is that because it's retrieving from enterprise ground truth,
Correct.
that is also associated with the semantic layer. So we have sort of check and balances, making sure that the right information is retrieved, and the large language model helps summarize that in a user consumable way to the user.
That's right. Plain text, plain language text, natural text, with some easy to create widgets if we want tables, if we want to format the answers in table, or maybe a pie chart in the future. That's something that would be able to do easily as well. But again, we use these different agents, right? Every agent is designed to kind of operate. So there's one agent for summarization, there's another agent that works on the query generation, another agent that works on the semantic modeling components, the model and the mapping pieces that we talked about. So that's part of the early setup of the system, is the semantic modeling and the mapping using the system that we have. And then from there, the execution, the question and answering is basically the summarization agent and then the query generation agent. So it's
So
like a
why
multi-agent.
doesn't every company has a knowledge graph? Because to me, the knowledge graph is
Absolutely.
somewhat akin to what in machine learning talks about, which is the embeddings.
Yeah, exactly.
It's the
Right.
representation of
It's
information,
represented.
perhaps in the knowledge graph here. You don't talk to your clients about the distance between the nodes and the vectors and etc. But it is a representation of knowledge. And in fact, the large language model rely on the representation of those large corpora to be
Correct.
able to generalize what they
Yes,
can do today. So
that's right.
why doesn't every company have knowledge graphs?
Yeah, good question. So knowledge graphs have traditionally been uh, uh, knowledge graphs have traditionally been considered as part of an evolving representation for uh, highly skilled knowledge workers, like so, like data science. Sorry, not data. Actual
Information services.
yeah, like scientists
Yeah.
in drug discovery, for drug discovery R&D in a pharmaceutical scenario, as an example, or knowledge workers they're specialized for the purposes of running compliance in a financial services risk area, where they have to understand all the policy related details, all the risk controls. So those types of knowledge workers. Now we're finally at a point where the same idea that we've talked about for these set of knowledge workers that need that data, but presented in context of sort of their domain, to now be in a position to say, you know what, every data element should be represented like that, not specifically designed for a subset of knowledge workers, but for everyone in the enterprise. The example you raised, that's an everyday question asked by the business, right? So your sales ops teams, your marketing ops teams, your revenue ops teams, everyone wants to know those types of questions. Your supply chain analysts, your factory floor analysts, right? Decision making at every level is data driven, and so what we've done traditionally is that, yeah, we'll build you dashboards, or let us know what you want to know, and we will have people who know SQL and Python, and they will put something together for you. Now we're just giving the power in their hands and saying, look, ask any question with regards to your domain that's encapsulated in the semantic data model, this represented in this knowledge, and this knowledge representation can take many forms, many shapes for many different domains, many different types of question and answering. It doesn't have to be one big, huge, massive representation of everything in the enterprise, right? That's not what we're trying to do here, boil the ocean. And so with Gen AI, that visibility has just gone to a new level, right? At the chief data office level, at the AI, at the chief AI folks that have now been anointed in the enterprises. Like, how do we enable Gen AI inside of our enterprise so that we can enable everyone in the business to ask questions? Well, you gotta make sure there's no hallucinations. You gotta make sure it's accurate. You gotta make sure it's grounded in truth. And current approaches with RAG that depend solely on vector databases just fall short of that, right? Because at the end of the day, you're still relying on, number one, the large language model as your system of information. That is a problem. Two, you lose privacy, especially if you have to pull all your data and schemas and push that into your large language model. And then three, at the end of the day, what are vector searches good for? They're good for things that are keywords that are semantically the same. They don't have the knowledge representation of the model and the relationships. And more importantly, because you're relying on the large language model to answer questions which are probabilistic by nature, which means their job is to give you an answer no matter how right or wrong it is. And the vector databases are only allowing you to say, okay, they asked about purchased, but we talk about buying. And so purchase and buying are kind of close in terms of the ask, in terms of that one idea, one concept. So I'll still give you an answer, but what it doesn't understand is how the relationship between purchase and products and orders and suppliers and customers and financial metrics. That's important in order to answer the question you asked, and then and be able to ground that in some ways. And that's the difference between your traditional RAG architectures versus the one representation that we have right now. We're calling it, and our CEO talks about it, safety RAG, right? SRAG. How do you ensure that you're supporting the idea of RAG, but doing it in a way that's safe and
Yeah.
responsible?
Yeah, and it's different school of thoughts.
Yeah.
And my personal view is that it's such an amazing time and exciting opportunity with both classical machine learning and Gen AI. It bring the importance of data science and machine learning AI to every organization. And now it's okay, we're sort of at the tail end of experimentation. What can we do with enterprise data?
That's right.
And with the RAG architecture is more of augmenting
That's right.
the large language model with the large language model in the centerpiece of providing 70 to 80% of the answer. And then there's 20% that will be retrieved or augmented by information from another database or another source.
That's right.
And that source may contain enterprise information, it may contain more updated information. But the key difference is the large language models are sitting in the front and center of that construct. And the RAG architecture is really augmenting versus what you're building is a completely different paradigm. What you're arguing with your client, saying to your clients, like, look, that may have its own use case.
That's right.
And people can try that. But in the world of enterprise data and just
Regulated
all these
industries.
different database, all these different things, the alternative approach, or maybe a parallel approach, is instead of putting large language models front and center in the middle as the engine that provide the answer from what's being trained in this large language model.
Those are expensive. We haven't even talked about
other corpora.
We haven't even talked about time and costs.
Right. We want to retrieve information or knowledge from enterprise data, augmented by large language model. It's actually reverse. It's the large language model augmenting the knowledge representation that exists from the enterprise data, and that evolve over time. And the large language model that you guys are using is really augmenting specific tasks in that journey of bringing the right representation of knowledge and the summarization of that knowledge and distillation of that knowledge to the front end user.
You got it, right? I mean, and why that matters, besides the fact that we talk about safety and no hallucinations and accuracy and timeliness, is also the time and costs. It is super expensive to
have large language sitting in the middle. Yeah.
In the middle, and training on the training exercises, the fine-tuning exercises with the corpus, as you mentioned, right, of your information, that, and with the GPU infrastructure, and just like with cloud and move to cloud, people are now reducing their dependency on cloud with the whole FinOps aspect, right? Financial operations in terms of cloud costs. Gen AI will carry the same challenges, because even right now, it's good when you're trying to do experimentation, and it's, whatever, 1,000 tokens per second or 1 million tokens per second, whatever ways that you're able to, OpenAI is able to charge the user in terms of the production of the information. Now try to do that at scale inside of an enterprise. So not only is it expensive to do the training and fine tuning on the infrastructure to support that, but now in terms of actual consumption, as you start to scale that across the enterprise, that becomes very expensive as well, right? Just the tokens per second that every question that gets asked. That is not a sustainable model, right? I mean, yes, do your experiments, but know that when you start thinking about putting this in the enterprise, understand the implications.
Thousands of users, real time.
Correct.
Yeah.
Apart from all the hallucination aspects and accuracy aspects that we talked about. Yes.
Yeah. I feel like we need to have a part 2 of this, because we haven't even talked about evaluation and safe AI. Those are also core to enterprise. But I think one thing I learned, among many things, the punchline is that I think Gen AI is one more tool in the toolkit, alongside visualization, alongside data engineering, classic, more traditional machine learning techniques, statistical modeling. This is another tool in the toolbox for different use cases that may make Gen AI more appropriate. But the lifeblood of business intelligence, driving decisions, using data, as you say, Navin, is enterprise data, the representation of that data.
Correct. Absolutely.
And then you can figure out what tools inclusive of Gen AI, when to apply that, how to apply that in a way that's safe and reliable for organizations.
You
So
got it.
we should definitely have a part two.
Do it.
Maybe this is an ongoing series.
Super.
And thank you so much for your time, Naveen.
No, I enjoyed it. Thanks for having me on, Josh.